All right, today we're going to break down a really interesting new paper that kind of turns our thinking about AI on its head. It talks about the illusion of deep learning and introduces a whole new way of looking at things called nested learning.
Okay, so let's dive right into the core problem facing even our most powerful AI today. I mean, think about how our own memory works, right? It's this dynamic, living thing that's constantly updating with new experiences. Now compare that to current AI. Its knowledge is mostly static. It's frozen in time after its initial training, and it only has this tiny window of short-term memory. And that fundamental difference, that's the huge challenge we're digging into today.
And this leads us to a really powerful analogy that the researchers use to describe the state of today's large language models, or LLMs.
Yeah, they compare these brilliant models to a person with anterograde amnesia, someone who can't form new long-term memories. It means the AI is basically stuck. Every new conversation it has, it's like it's meeting you for the first time, all over again. Any information you give it right now is just temporary. It never really gets absorbed into its core knowledge.
So here's the bottom line. Once an LLM is trained, its core knowledge is pretty much set in stone. This is exactly why your AI assistant can't just remember your preferences from one day to the next without some pretty complex workarounds. It can use what you tell it right now, but in the next conversation, poof, it's gone. It's this brilliant machine that's fundamentally stuck in the past.
You know, for years, the go-to solution for making AI more powerful seemed almost too simple. Just make the models deeper. Just keep stacking more and more layers on top of each other.
But here's the thing. This paper argues that this whole approach is hitting a massive wall. It just doesn't solve some of the biggest, most fundamental challenges we're facing. It's like thinking that just adding more floors to a skyscraper will automatically make it a better, more functional building.
And this slide really breaks down why that just go bigger approach is failing us. Stacking more layers might give you a bigger model, sure, but it does nothing to solve that core memory problem. And the real kicker, which you can see right here, is that this method completely fails, like zero improvement on the model's ability to adapt or continually learn. So we're building these incredibly tall towers, but they're not getting any smarter or more flexible.
Okay, so this is where things get really interesting. The researchers propose a radical new perspective, moving beyond that flat, stacked view of AI to something much more dynamic and, well, alive.
So to really get this new idea, we first need to understand a concept called update frequency. It's actually pretty simple. It's just how often a specific part of the model learns or changes its mind. You can think of it like a learning pulse rate for different parts of the AI's brain.
And this image of the gears, it's the perfect way to picture nested learning. Instead of seeing an AI as just a stack of layers, you see it as a system of nested processes, all learning at different speeds, just like the gears in a really complex watch. Some of these gears turn with every single new word, learning on the fly, and others, they turn much more slowly, consolidating knowledge over longer periods of time.
So what does this actually mean? Well, it means that different parts of the model are constantly solving their own little learning puzzles, but on totally different timescales. And this structure, this is what allows for both lightning-fast adaptation in the moment and that slow, steady formation of long-term knowledge. It's actually a lot closer to how our own minds seem to work.
So you're probably wondering, how does this actually work in practice? Well, here's the crazy part. It turns out we've kind of been using a very simple form of nested learning for years. We just didn't realize it. Let's take a look at an old tool in a completely new light.
Okay, let's start with the absolute basics, gradient descent. This is the simplest training algorithm out there. You can think of it as a one-level learner. It sees a piece of data, and it makes one single, direct adjustment to the model's internal knobs, or weights. One input, one update. Super straightforward.
But now, let's add a really common little tweak, momentum. The paper points out that gradient descent with momentum is actually a two-level nested learner. That momentum term, it acts like its own little memory module. It's learning from all the past updates to help inform the next update. It's a system within a system.
And that right there, that is the big aha moment of this whole paper. A common tool that data scientists have been using for years is actually a simple nested system just hiding in plain sight. And this one insight gives us the blueprint for how to design the next generation of truly adaptive AI. Only this time, we can do it on purpose.
So taking this huge insight, the paper then introduces a brand new model that's designed from the ground up with these nested learning principles at its core.
It's a model called HOPE, and it's built around something they call a continuum memory system. Now, that's basically a fancy way of saying it's an AI that's been intentionally designed with all those different learning speeds, those nested gears we talked about, built right in from the start.
Its very structure is made for creating memories at multiple speeds. And you can literally see the difference in the architecture here. Instead of a simple, flat stack of repeating blocks like a standard transformer, Hope has this more complex structure that's specifically designed for multi-level, multi-speed learning. It is architecturally built to avoid amnesia.
So does it actually work? Well, the results are pretty darn promising. This table compares Hope to another state-of-the-art model. Okay, let's break this down. Perplexity, you want that number to be low. It basically measures how confused the model is. And as you can see, they're nearly identical. But now look at average accuracy. You want that to be high, and Hope actually edges out the competition. This shows that the nested learning approach isn't just some cool theory, it has real-world power.
So all of this brings us full circle, right back to that AI with amnesia we started with. But now we have a potential solution in sight. Nested learning offers a real path towards models that can truly grow and adapt over time. And that leaves us with this final and pretty provocative thought. If an AI can learn how to learn by changing its own rules for learning, what will it decide to become?